In the next few days, we will be looking at being logged out due to inactivity. No, we will be looking at algebra and reviewing and multiplying polynomials today, but then tomorrow and Friday and Monday, we are looking almost exclusively at factoring. Okay? So these are some pretty serious topics from, let me see if I can find where I did this, from algebra that you need to know for this section of geometry, which is why we're spending a little time reviewing it. But they're also going to be just major topics for Algebra 2 HI. Here we go. I 2014. There we go. I haven't posted this online yet either, but it's basically worksheets all through Monday, and this entire benchmark is based on those worksheets and algebra. So basically, this I1 benchmark, Unit I actually I think has 4 quizzes. Last unit only had 2 quizzes in a test. This one has 4. So it's this is a long unit. It's because we kind of put this thing with algebra on the beginning. And if you are taking Algebra 2 next year, especially at any level, whether it's intermediate or regular or honors, it doesn't really matter. Factoring really figures in there. So being good at factoring is going to be important. Well, you know what? It's really not so bad. Yes, it's a process. But if you compare it to a lot of the processes we've had to learn in geometry this year, I think you may go back at this year and look at it and go, really? That's not that bad. It's just a little bit of number manipulation, and we can come up with the answer pretty much every time. But as we do with factoring, whenever we teach factoring, whether it's forward, backward, whatever it is, in algebra, Algebra 2, pre-calculus, we talk about factoring again. Again, it doesn't go away. We were factoring in just this week several times in pre-calculus, so it's just something we keep doing. We start by looking at the process in reverse, which is distributing and FOILing and multiplying monomials and polynomials. So this is really for the next 5 days an algebra class. Yay. And then we'll get back to geometry and the circles and stuff like that. So a little bit of a break just from regular old geometry here. I know that's going to break your heart to have to do some algebra for a few days. By the way, just a final reminder, if you have any makeup work or anything that you've requested for makeup tests in the test center from Unit G, which is when we started the semester with, you have to have those in by Friday. I'm going to be going through there, and just anything that you requested for retakes for G that are not retaken are just going to be taken out. So grades will be final for G by the end of this week. If you have any retakes there, get them done. Yeah. Yes, it is. And if you have an H2 retake, I'll get it back there shortly because I got the right version. Multiplying monomial terms. Now remember, we have to look at our different terms. Monomial meaning one number. Now, some people say, wait a minute, there's a 6 here and an X. That's not mon, that's 2. By monomial, I mean one term, because this is a term by itself, the 6x's. It only becomes a polynomial or a binomial meaning 2 when we put a plus or minus between terms. That's how we get polynomials, is by adding monomial terms. So the vocabulary here, a little different. Algebra stuff that we've seen before. But again, multiplying is pretty easy when we're dealing with this sort of thing. We multiply the whole numbers times the whole numbers, so 6 times 10 is 60. I have 1x here, x squared here, so that's going to give me x to the third. Okay? 4mn squared times 3m cubed n. Again, we multiply the number parts. 4 times 3 is 12. M times m cubed is m to the n to the third. Okay? You remember this stuff. That's easy, right? It's just combining terms, basically. Distributive property is the next level of this. This is where we multiply a monomial times a binomial or monomial times a polynomial. The biggest thing to remember with distributive property, and we've been working with this all year with numbers and stuff like that, so you've seen it, is we do have to remember to distribute. Not just do the A times B, but also the A times C. So here, not just the 5 times X, but also the 5 times 4. I always like to think distributive property, if you don't distribute everything inside the parentheses equally, someone's going to be mad. I mean, if I was passing out $100 bills, and I was distributing $100 bills to people in this classroom, and I skipped you, how would you feel? Everybody in the room got a $100 bill but you. You wouldn't be happy with me, would you? You would definitely be unhappy. Why? Because you didn't get what you're supposed to get. Well, same thing here. If this 5 doesn't go to the X and to the 4 is going to be, if it only goes to the X, the 4 is going to be mad. You have to distribute that way. We're just multiplying numbers. I can multiply a term the same way. 6n times n is 6n squared. 6n times 5 is 30n. If I'm distributing a negative, it's fine. Negative 4 times 3n will be negative 12n. And negative 4 times positive 7 would be negative 28. And negative 8t times negative 4, positive 32t. Negative 8t times negative 9t, positive 72t squared, right? And of course, what we're going to be doing when we're factoring tomorrow is we're just going to be working this whole process backwards, aren't we? Instead of starting with this and ending here, it's just the whole process going backwards. Decomposition. Instead of composing it, we're decomposing it. That's what factoring is. Because remember, this is essentially multiplying. Distributive property is multiplying. Factoring is a form of division. The undoing of multiplication is division. The opposite of multiplication is division. The opposite of distributing is factoring. Multiplying binomials. This is FOIL. Biggest problem people have with multiplying binomials is they just want to go, okay, x times x and 2 times negative 3, and I get x squared minus 6. It just doesn't work that way. We have to multiply everything out. So remember our FOIL. You remember FOIL, right? The idea of FOIL. Multiply the first terms. X times x gives me x squared. You can color code it. The outside terms, x times negative 3 is negative 3x. The inside terms gives me a plus 2x. And the last terms give me a minus 6. And I combine, often the outside inside, the OI, often combines. Negative 3x plus 2x, excuse me, gives me negative 1x. Okay? And we get a quadratic as a result. A quadratic is a term that's something x squared plus an x plus a constant. Or plus or minus, for that matter. Foiling this one. Again, first outside, inside, left. One thing at a time. 2 times negative 3x is going to give me what? Negative 6x squared. Outside, 2x times 1 is just 2x. 7 times negative 3x minus 21x. And 7 and 1 is a 7 that we combine like terms. That's going to give me negative 6x squared minus 19x plus 7. And again, with factoring, what do? We start here and we work our way backwards to that, don't we? That's what we're going to be doing with factoring. And FOIL is pretty easy. We just have to take our time. As long as we take our time, this is not bad. X times 5x, 5x squared, minus 9x minus 60x plus 84. I'm sorry, 104. No, 9 times 12, 90 plus 108. Thank you. Sorry. Brain malfunction. So 5x squared minus 69x minus 108. Okay? plus 108. Thank you. Okay? So all sorts of little things going on there, but not terribly, terribly difficult stuff. One way we can solve simple quadratic equations, and we've kind of done this a little bit before, but it's solving by the process called extracting roots. And basically extracting roots means we get x squared by itself and take the square root of both sides. And we're going to look at that most simple method of solving a quadratic that we can get. So if I have something like x squared equals n or x squared plus b equals n or something like that, it's a quadratic. You know, a quadratic formula or quadratic equation always looks like ax squared plus bx plus c equals 0. That's a general form of a quadratic equation. You covered that a little bit in Algebra 1 too, didn't you? And you probably learned the quadratic formula, which we'll talk about later. But in these situations, the middle term b is gone. All right? There's no middle x term, which means we can solve using this process called extracting roots. Or we can just get the x, simply said, we can get the x squared by itself. So if I have something like x squared equals 16, I just take the square root of both sides. However, since we're working in algebra right now and not in geometry, so x is not representing the length of something. Always in geometry, when we've done this before, like if that was the hypotenuse of a right triangle or something like that, we just say, well, we'll just give 4 as my answer. I won't worry about the negative 4 solution. But not, because we were indicating a length, and length can't be negative. But here we're just solving for a variable. So when I do this, square root of x squared is just x. The square root of 16 actually is positive or negative 4. You have two separate solutions. One is positive 4, one is negative 4. Why? Because positive 4 squared is 16, so is negative 4 squared. Both actually work. And because we're no longer just talking about segment length or something like that or angle measure, we can go ahead and have a negative value for x. It's not a problem for us. So the big thing we have to remember is to not forget the plus minus when we're taking a square root. We're working algebra. And just here are some basic sample problems. Again, before you take the square root, you want to get the x squared by itself. So divide by 3, I get x squared equals 25. So that means x equals positive or negative square root of 25, which would be 5. Here, I'd subtract 10 from each side. X squared equals 81, so x is positive or negative 9. If it's a little more complicated like this, you might have to do a couple steps first. Add 3 to both sides first. 2x squared equals 8. Then divide by 2. X squared equals 4. So x equals plus or minus the square root of 4, which is plus or minus 2. Get any idea on this? It's pretty basic algebra. It's not requiring anything fancy. Do we always get nice numbers? Not always. 3x squared minus 7 equals 18. If I add 7 to both sides, I get 3x squared equals 25. Divide by 3. So I get x squared is 25 thirds. So x equals plus or minus the square root of 25 over the square root of 3. What? Am I allowed to do what? Take the square root of a number that isn't? Do what? Yes. What's the square root of 25? So that's positive or negative 5 over the square root of 3. We aren't done yet. You said you could leave it like that. No, he said, can I do that? I said, yes, we can do that. We can't finish like that. We then rationalize it. So that's plus minus 5 root 3 over 3. And we spent a lot of time going over how to rationalize radicals and simplify radicals. So, yeah, our solutions aren't always going to be nice. Sometimes they are. Sometimes they aren't. 5x squared equals 1,000. Divide by 5. I get x squared equals 200. So x equals positive or negative square root of 200. Square root of 200 is square root of 100 times the square root of 2. Again, plus minus. Square root of 100 is 10. So positive 10 root 2 and negative 10 root 2. So yeah, so we're extracting roots. We do have to simplify and leave things in simplest radical form. And for some of you, that's going to be the biggest challenge, is simplifying the radicals. Now, again, when quiz and test time comes, if you were to leave that as positive or negative square root of 25 over 3, you'd have at some points taken off, but you could certainly get some credit for that, because you have extracted correctly. You just haven't simplified. But almost everything we're seeing today is pretty much a level 2 style problem. Very basic information that everyone should be able to do. And that's what the homework is tonight. It's just some basic algebra. It's a worksheet, 1 page front and back of some algebra. Should be very easily able to get through this. Even probably in the time that remains in class today, because we have until 11:02. That's 15 minutes. That should be more than enough time to finish this worksheet in class. Okay? So, not too horrible.